Hi, this is your favorite tutor, the science and mathematics tutor, Yomi Omorewa. We're looking at a very important topic in chemistry, whole important topic actually. And I want us to join in together this morning as I explain this topic in detail. And I'm telling you, you're going to understand perfectly as we join in together into this amazing topic, periodic table. Now, what's periodic table? You may want to ask. Actually, periodic table has to do with the arrangement of the elements. You know, there are about 118 or maybe more elements in the periodic table. And these elements, the way they are arranged in the periodic table in order of their atomic number, which is the proton number, is what we'll call the periodic table. Okay, so it's arranged. Okay, and there's a law that also guides the properties of those periodic that guides the periodic table. So we're going to be looking at that as well. So let me give you a skeletal periodic table for the first 20 elements, for example. So here you have hydrogen, right? So down here you could have lithium, and down here you could have sodium, and down here you have potassium, okay, because they are group 1 elements. And somewhere here you have your helium, okay. And so if I have my helium there, then I could have what we call here beryllium, and here I could have my boron. Here I could have my what now? Carbon. I could have my nitrogen. I could have my oxygen. Okay, this space. So let me bring this closer. I could have my fluorine. I could have my neon. So because they belong to the same. And so here I have magnesium, here aluminum, here silicon, here phosphorus, here sulfur, here chlorine, and argon. And here I have calcium. Okay, so this is the skeletal table for the first 20 elements. Okay, so for the first 20 elements, you have your hydrogen to calcium. Now, in the periodic table, there are 7 periods and there are 8 groups. Okay, now the periods are the one that you consider. For example, this is period, the horizontal. Horizontals are periods, while the vertical are the groups. Okay, so there are 7 periods and there are 8 groups. So when you move like this, you're moving across the periods. When you move down like this, you're moving down the group. Okay, so this is like period 1, this is period 2. If I say let's go to period 3, you are talking of this period that begins with sodium, so like this. And then when you move down again, this is period 4. And so we have them like that, till you get to antinide and lanthionide. That's the last period there. And so 7 periods. And then we have 8 group. Like you have group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. Or what you call the group O. Okay, so that's how you are. So you have 7 periods and 8 groups. Now, what again you need to understand here, the about 108 elements are classified into various sections. So you have the metals, you have the non-metals, you have the metalloid. Not only that, you have the metalloid, then you have the noble gas. You have the transition elements. You have the antinides, and lanthanides. So the antinnites and lanthanides are the one we call the inner transition elements, okay? And I think they begin from a very high atomic number, okay? They are radioactive elements mostly. So metals, example of metals here, okay? Let me use here now. Example of metals, you could take sodium, you could take potassium, you could take magnesium, you could take calcium. That's metal. Example of non-metals, you could take phosphorus, you could take sulfur, you could take chlorine, you could take oxygen, you could take nitrogen. Example of metalloids, well, I can manage silicon, but I prefer germanium, okay? So for metalloid, that is in between metals and non-metals. An example of noble gas, you could take helium, you could take neon, you could take argon, you could take xenon, you could take radon, and so on. And the transition elements are not here. The transition elements are the ones that are in between the group 2 elements and the group 3 elements in the periodic table. So it begins with a particular element called scandium. Scandium has 21. Okay, so from 21 like that, you have your transition element down. In fact, scandium is a transition element, copper is a transition element, iron is a transition element, chromium is a transition element, and vanadium is a, and all of those things are transition. Even zinc is a transition element, and of course, there are properties of transition elements, and we're not going into that for now. Now, then, so we talked about antinite. Your plutonium is a classic example of that. Okay, your thorium is an example of that. Even your popular uranium is an example of antinite. Your lanthanide, your cerium is a... In fact, lanthanide begins with cerium. Lanthanide begins with cerium, okay? So it is important you know all of these examples as I've stated them even here. Now that takes us to what we call the periodic law. The periodic law. What does periodic law state? The periodic law states that the properties of the elements, okay, are the periodic function of the atomic number. Stay with me, stay with me. The properties of the elements are the periodic function of the atomic number. Now, do not forget, I said earlier that the periodic table is arranged in order of what? Atomic number and not atomic masses. Don't forget that. It's in order of increasing atomic number. And so the periodic law now, still based on that definition, that is the periodic function of the atomic number. So it's always based on atomic number. I think it was this man called Henry Moseley. That's how I used to call the name. This was the man that did justice to that. Yes. Henry Moseley. Yes, Henry Moseley. So we should applaud him for the contribution that he made in the periodic table as well. Of course, Mendeleev also did an amazing job. In fact, he did the greatest job in the periodic table. Now, so we go back to those properties. So what property? Number one, atomic radius. And ionic radius. Number two, we have ionization energy. Number three, we have electron affinity. Number four, we have electronegativity. Electronegativity. So this is number five. We have, of course, electropositivity. Okay, so These are various, of course, we have other physical properties such as conductivity, electrical stuff, metallic stuff, and all that. So, when we are considering all these properties of the periodic table according to the periodic law. Okay, we state that the properties of the elements are the periodic function of their atomic number. Okay, so now let's pick them one after the other as we try to save time. So what is atomic radius, okay, and what's ionic radius? How do you compare these two now? Okay, so atomic radius is just talking about the size of the atom, right? So it refers to the half distance. It refers to the half distance between the nucleus and the outermost shell. Okay, between the nucleus and the outermost shell. That's what it's saying. That's it. Between the nucleus and the outermost shell. Okay, so that's what the atomic radius is talking about. So when you look at the periodic table, your atomic radius decreases down the group, but when you go down the group, it decreases across the period rather. Okay, and of course the reason is not far-fetched. Across the period, there's increase in the nuclear charge. It will be explained, don't worry. So across the period, there's increase in nuclear charge, but down the group, atomic radius increases because of the increase in the number of shells. So if you look at this now, let's say this is like you have another thing like this. You'll discover that it will be farther than this. If you have another one, so as the number of shells increases, the atomic radius increases, okay, down the group. Take note of that. And the ionic radius also has the same trend as atomic radius, yes. But there's something you need to understand here. If you have the cation, which is this, and its corresponding atom, this is 2, 8. This is 2, 8, 1. The ionic radius, okay, for ionic radius, its atom is larger than its corresponding cation. For ionic radius, this is not something to argue about. But for anion, this is 288 and this is 281. For anion, its corresponding ion has a larger atomic radius compared to its atom. Okay, can you see that? Let me repeat again. For cation, that is the positively charged, the atom has a larger atomic ionic size than its corresponding ion, while the reverse is the case here, because this one is gaining electron while this is losing electron. I think that's pretty simple, right? Very simple and straightforward. That takes me to the next one called ionization energy. Ionization energy is very simple. It's just telling you the energy, minimum energy that is required to remove an electron, okay, from an atom or a loosely bound atom to form an ion, okay, or a gaseous ion. So what ionization energy is all about is loss of electron. It's a loss of electron. How do you know there's a loss here? This is the oxidation state of this is 0. The oxidation state of this is what? 1. Okay. So if you look at it now, it increases from 0 to +1, and that's what we call oxidation. And what is oxidation? Loss of electron. And that loss of electron is ionization energy. I've said a lot of things just now. So ionization energy basically is a loss of electron. You need to know that. Okay, so there's what we call the first ionization, the second ionization, and the third ionization. Now, what is the trend of the ionization in the periodic table? The trend is that As you move from left to right, that is from the metals to the non-metals, ionization energy increases. And the reason is not far-fetched. It is because across the period, there is an increase in nuclear charge. What do we mean by that? Let's move to period 3, for example. In the period 3, we have something like this. We have something like this. We have something like that, and so on. What happened here? This is 281, 3 shells. This is 282, 3 shells. This is 283, 3 shells. And this is 284. See 3 shells. What do you observe? You discover that in the outermost shell, the number of protons increases by 1. Am I correct? Yes. Okay, so you can see here 1. This is 2. This is 3. And this is 4. But yet, the shells remain the same while the number of protons increases. As the number of protons increases, the more it increases, the more difficult it is to pull electron from the outermost shell. Okay? Because when we say nuclear charge, we are talking of the positive charge in the nucleus. That's nuclear charge, the positive nucleus in the nucleus. Okay, remember the nucleus is positively charged because there's a proton there, and the more the nucleus is charged, the more electrostatic attraction between the nucleus and the outermost shell. And so when the number of protons is increasing in the outermost shell, the nuclear charge also increases along. Okay, that's very important. So but down the go, ionization energy decreases. Yes, it decreases because of the increase in atomic radius. Okay, do not forget I said the atomic radius increases down the go. Yes, so because of the increase in atomic radius, ionization energy decreases down the go. You might want to say, does nuclear charge not have effect down? Well, even if the effect is there, it has been conquered and crushed and superimposed by the number of shells that is being increased down the go. So it's like superimpose it or counter it and overcome it. So the nuclear charge effect is minimal and almost inconsequential, almost very negligible as you consider it down the go. I'm sure I'm not sounding too high for you. I'm sure you're getting what I'm saying exactly. So down the go, it decreases. Across the period, it does what? It increases. Don't forget that. And are there factors that affect ionization of energy? Obviously, there are factors. And that I'm going to be explaining in another video. Okay? I'm going to be explaining that. There are 5 factors that affect ionization energy. Number 1, we have the atomic radius. Number 2, we have the nuclear charge. Number 3, we have the screening or shielding effect. Number 4, we have the stability rule. Number 5, we have the type of orbiter. These 5 things affect the ionization energy, but we're not doing that now. Let's come to electron affinity. Electron affinity is more or less like almost the opposite of this, because why am I saying that? Electron affinity is gain of electron. Okay, so it's telling you that when a neutral atom, when a kind of how do I put it now, is added, when there's an addition to a neutral gaseous atom, when there's a kind of addition to a neutral gaseous atom. So electron affinity is a gain of electron basically, because across the period it increases. Yes, electron affinity. The word affinity is like a law. It's like love. It's like an attraction. It's like love. So as you move down the go from left to right, you will observe that the metals don't have affinity for electron, but rather they lose. Okay, so it is the non-metal that have affinity. This is why as you move across the period, electron affinity increases across the period. But as you move down the go, what happened? It decreases, because as you move down the go, what happened? The metallic character increases. So metal don't attract electron to themselves. It is non-metal. And so take note of this. So it increases across the period, but decreases down the go. What's the next to the last, electronegativity rather. This is talking about the ability of an atom to attract electron to itself. Okay, what does that mean? Do metal attract electron to themselves as I explained earlier? No. So it is the non-metal. That's why the halogens, I think, have almost the highest. They attract electron to themselves. And so electronegativity too increases across the period, but decreases down the go. Because generally, metals will not attract. They will rather what? They will rather release or lose. Okay, it is the non-metal that attract electron to themselves. And so the opposite of electronegativity is electropositivity. It decreases down the go, right? Because you expect it to be like that. Because as you move down the go, the ability to attract electron, the ability to exhibit metallic behavior and character is decreasing, so it will decrease. But as you move down the go, ability to exhibit metallic behavior or character increases, and so you expect electropositivity to increase. So basically, you need to understand what I've said so far. I talked about the definition, and then I talked about the classification of the periodic table. I talked about the periodic law. I talked about the properties of the periodic table, which I've explained to you now. And I also gave an explanation today. Then I said in the next video, I'm going to be talking about the factors that affect ionization energy. So you look forward to that video and see. I'm going to be explaining that. It's going to be mind-blowing. So you need to watch out for that video. Okay, so if you have any question on anything you're not clear with, you're free, you're at liberty to ask question and to drop in the comment section. But before I go, note this quickly, that this and this increases across the period, but decreases down the go. This and the first two that I explained increases down the go, but decreases across the period. Till I come your way again, I remain my humble self, Tutor Yomi Omorewa. Bye.